So yes, welcome. We're going to start lesson 5 today. We are in, so we finished, we're all the way into week 8. Week 8, right? We finished our first exam, which covered lessons 2 through 4. This is February the 24th, so here's where we are, right? Starting lesson 5. And lesson 5, we're going to introduce our perhaps we'll cover at least 2 types of loops today. And then what are we going to do next week? How do we prepare for next week? We're going to continue going over next. I need to change that. Sorry, that's supposed to be a 5. We're going to finish chapter 5 next week. And there are no assignments due on next Friday, right? But we do have an assignment that's due the following Friday. We do have a guest. I've invited a guest to come speak with you all, not next week, but the week after next. I'll give you some more details about who that is and how to prepare for our guest, okay? And I love when he comes and talks to the students and gets you thinking about working in industry and thinking about, what you need to be doing to prepare yourself for your next chapters in your lives, right? As you start preparing yourself to enter the workforce. And so Lester is going to come and talk with you all in a couple weeks. So we'll talk more about that as that date approaches. All right, so here's where we are. We are going to go to modules, and you can follow along with me in the lecture notes for lesson 5. We're in lesson 5, okay? Lesson 5, and so in the lecture notes there, we're going to talk about loops. Why do we even need them? Okay, first of all, every language has a way to represent the idea of a loop, okay? And so before we even get into the nitty-gritty of it, or what it is, and hopefully today I'm going to introduce lesson 5 to you so that as you're going through your reading assignment and your exercises, right, this will hopefully better prepare you for that. Why in the world, can anyone tell me, why in the world do we need loops? Why? Why do we need a way to talk about loops? Why do we need a way? Anybody have an idea? What is a loop? Why do you think we need them? Why do we need those types of structures? Anybody? Anyone out there? Am I talking to myself today?
I'm here.
Okay, Chancellor. Anybody have a clue? What is a loop? What is a loop? And we'll fix it if it doesn't make sense or we need to add on to it. It makes code more organized. Okay. So tell me this, what types of problems, because that's why we introduce these concepts, right? The last lesson, what did we talk about? We talked about branching statements, right? So if you're in a fork of a road and you have decisions to make, you can either go to the left or go to the right. So you will either execute this block of code or execute this block of code, but you won't execute both, right? So we introduced the last lesson, we introduced branching statements, right? Which allowed us to control the flow of our program based on some Boolean expression. And so it says here, so it runs a set of code 1 or more times, Logan. Absolutely. It's more efficient to loop through a statement rather than writing it several times. Absolutely, Alexander. Very good. And so guess what? You've probably had, let me see this. Have you experienced a loop today in your life? Anybody experienced a loop? You think? And something that you did today? If so, share. Because we want to see, not only learn about these concepts, but you need to know that this is a tool you have in your tool belt. But when should you use this tool? When should you introduce this tool, this concept in your program? What types of problems would I say, I think I need a loop? What types of problems do you think? What types of examples that you may have experienced today? Any ideas? Something you might have done today? Did anybody log into anything? Like, for instance, you log into the application and maybe you put in the wrong password, and it kept asking you to enter the, You put in a password and you push enter, it says it's incorrect. You put in the password, you enter, and it says it's incorrect. You finally put in the correct password, and then it allows you to gain entrance to that application. Has anybody experienced that before? Yeah, right? Of course, right? We have. Well, things like that's just an example. That's an example of a loop, right? When certain conditions are met, I'm going to repeat something until a certain condition is met. Imagine if we were to code or program a robot, right? We're going to tell this robot, walk, like pick your right foot up, pick your left foot, pick your right foot up and put it down, pick your left foot up and put it down, meaning walk until you, let's say walk until you walked 50 steps. Does everybody hear what I just said? So we're going to tell the robot to walk 50 steps and stop. Walk 50 steps and stop. That's what we're going to tell the robot. Walking consists of picking up and putting down your right foot, picking up and putting down your left foot. That's what walking consists of. So what do we want the robot to repeat? Put it in the chat or unmute yourself. What do we want the robot to repeat? We said we wanted to walk 50, we wanted a robot to walk 50 steps. Walking consists of putting up and down your right foot, putting up and down your left foot. What do we want the robot to repeat? So yes, picking up your left foot, picking up your right foot, right? That's what's going to be repeated. Picking up that right foot, put it down. Picking up that left foot, put it down. That's what that's what we're saying it is going to simulate walking. So those are the actions, those are the commands that we want to repeat. Now, you all tell me this. So the picking up left foot, right foot, left foot, right foot, left foot, right foot. Tell me, when should we stop telling the robot to pick up their left foot, pick up their right foot? Tell me when, under what circumstances should we tell tell me this. I'll restate this. Under what circumstances should we tell the robot to continue to walk? Under what circumstances should we tell the robot to continue to pick up their right foot, put it down, pick up their left foot, put it down? Under what circumstances? Let's just talk. Don't think about code at all. Just think. Until they have walked 50 steps. Absolutely, Christina. It's not, exactly. High five to all of you all who are participating today, because that's what this is all about. Okay. I'm not over here just talking to myself. And if you can share your faces, oh, that would make my day. I'm trying to tell you. Thanks, Chase. I'm over here by myself, okay? So yes, thank you for that. And anybody else, feel free. I love to see your smiles. Yeah, so picking up your right foot, pick up your left foot, stop until, right? Keep walking until you reached 50 steps, Christina, right? And so that's the condition. That's our Boolean expression. And so we're going to learn how to write statements like this, because we have loops in our lives on a daily basis, right? So we've got to have some way to simulate that idea, that to be able to convey that idea of repeating one or more commands, one or more statements until some condition is met. It happens on a daily basis. Just like last lesson, I'm going to drive, and if the light is green, I'm going to drive through. If the light is red, I'm going to stop my car. That was a branching statement. We had choices based off of the condition of that light, determine what I was going to do next with my car. That was a reason to introduce a branching statement, an if-else statement, or a switch, right? So when in the world would I introduce a loop? Just like what the word means, loop. It means we're going to repeat. How often should we, how many times should we repeat is all determined based on the condition. And so that's what we're going to learn today. Some fun stuff. Okay, so let's get going, rocking and rolling. You can, like I said, you can open up your slides and you can follow along with me on the slides as well, but make sure you have your programming environment open, because we're going to write some code. Matter of fact, I'm going to go immediately to my programming environment and I'm going to prepare for taking notes. So we're in lesson 5, you all. We don't have that many more lessons left. So let's go ahead and click on lesson 5, and we're going to create a new folder for lesson 5. Let's call this one notes. So this is for my notes for lesson 5. And then I'm going to create a note for today. So this is the notes for today's discussion, and I'm ready to rock and roll. So there it is. Okay, there's my notes for today. And so with that being said, what in the world are we going to talk about today? We're going to talk about definitely loops. And so here in our discussion, if you notice, there's 3 types of loops that exist that we're going to talk about, and not necessarily in this order. Okay, we're actually going to start our first discussion on the while loop, but there are 3 types of loops that exist. 3 types of loops that exist. So let's just put that down here. So the first thing that we want to know is that there are 3 types of loops. All right, 3 types of loops. One is what we call the while loop. While loop. Okay. The second type of loop that exists that we're going to go over is called the do while loop. And then the third one that we're going to go over is called the for loop. Okay. So that's what we're going to go over in that order. We may not get to the for loop. We'll get to the for loop on next week, but definitely the while and perhaps even the do while. Okay. So these are the 3 types of loops that exist. And we're going to learn when to choose. Let me restate this. We're going to learn which loop is more efficient than the other, depending upon the problem that we're trying to solve, right? So we can solve our problem using either one of these loops, but which one is more efficient? And that's all based on the problem that you're trying to solve, right? That you're trying to address. And so the while loop is the first one that we're going to go over. And here's just a brief little summary. The Java while loop is used to iterate a part of a program several times. If the number of iterations is not fixed, it is recommended to use a while loop. So we'll talk about what that means and what the difference is between a do while and a while. So here is when I would say you would want to. Here's an example of a simple example. It's a rather simple example of a motivation, right? A motivation for writing a loop is, what if we wanted to write welcome to Java 50 or 100 times? What if I wanted to write it 100 times? Do you think it's more efficient to write system.out.println welcome to Java 100 times? Should I copy and paste that line of code 100 times? Does that make sense? Does that sound like a fun task to do? I don't think so. There's a more efficient way than copying and pasting that system.out.println statement 100 times. No, there's a better tool. The tool called a loop. We can shove that line of code inside of a loop, inside of the body of a loop, and we would craft our Boolean expression to make that statement, make the body of that loop execute 100 times, right? And control, that print statement so that it only prints 100 times. So we have a more efficient way to approach a problem like this. And we would, again, use a loop. So again, we have 3 types of loops that exist. These, whenever you think of a loop, think of it in terms of this, that whatever you put inside of a loop, we call that the body of a loop. Okay, so whatever is in the body of a loop, right, is what we want to repeat. Just like I mentioned at the very beginning of class, I said, well, what if we had a robot and we wanted the robot to walk 50 steps before it stopped? Well, what do we want to repeat? You heard me ask that question. I did it intentionally because whatever we want that robot to repeat is what needs to be inside of the body of the loop. Okay, so whatever we want, so whatever statements. So what is the body of the loop? The body of the loop contains 1 or more lines of code that you want to repeat. 1 or more. It could be 1,000 lines of code or 1. So again, 1 or more lines of code, right, are going to be in the body of a loop. Those are the statements that you want to repeat based on some condition. And so 3 types, let's talk about them. So I put this diagram in your, and I don't go slide by slide whenever we're looking at your notes, but those notes that I put together are definitely for you in offline, so you can look at them and refer to them for further explanation. But I like this diagram, this chart here, because it gives you a good compare and contrast between the 3 types of loops that exist. You can see the the syntax differences between one and the other. You can see an example of how each are written, right? And so this is a great, this chart right here explains lesson 5 to a T, almost, without, there are 2 concepts that you don't quite go over in this chart, but yeah, so this is a very good diagram to, and we'll refer back to it definitely a little bit later. So what I want you to appreciate is the following, that every single loop has these 3 things. Now, I like to emphasize this because it's a little checklist, right? Right, when you're writing a paper, you like to have an outline, right? You have to have, you know, guides how you write your paper. Well, whenever we talk about a loop, all loops should have these 3 things. These 3 things, and I'm going to emphasize them when I introduce every loop, right? All 3 loops, right? So here, let's write this down as we go through these 3 things that every single loop has. Let's talk about them. Hold on just a second. I got rid of my chart over here. All right, so here, what do all loops have? So these are our 3 loops. We're going to go into those 3 loops, I promise, but I'm going to make some room up here at the very top. I'm going to make some room up here at the very top because I want us to talk about all loops have these 3 things. Okay, all loops, I should say should. All loops should have these 3 things. And there's a reason why I'm saying should, but yeah, all loops should have these 3 things. Let's go ahead and commit this to memory, okay? Let's commit this to not memory, understanding, okay? You want to understand it. What in each one of these 3 things we have a reason for including them, and where they are with respect to each loop differs. So what's the first thing that every loop is going to have? Every loop will have a statement where we initialize something that's called your control variable. So what is a control variable first? So a control variable is a variable that controls how many times you execute the loop. Here, let me just say this. So let's put a little note here. So first of all, let's put what the requirement is. The requirement is that we must initialize the control variables value. So put that there for me, please. And I'm going to put a little parentheses here, CV. You're going to hear me call it the CV for short. That's your control variable. So what should every loop have? Every loop should initialize the control variable's value, meaning give that control variable a what we call a seed, a starting value, It doesn't have to be 0, 1, it's whatever. It could be 1,000. It just depends on the problem that you're working on, but you got to give it a value. A value has to be in memory for that variable before the loop starts. So let's talk about the purpose of a control variable. Let's talk about a control variable. So what is a CV? What is a CV? Control variable. The control variable determines how many times the loop repeats. So that control variable controls the number of times that loop executes that variable. And again, it just depends on the problem, but you've got to have some variable, a variable that is going to control how many times that loop is going to repeat. And we call that variable the control variable, okay? That control variable. So we've got to give, so before we get to the loop, you've got to give that variable a seed, an initial value. So let's put that there too. I'm gonna put that, the CV must be given an initial value prior to the loop. Okay, and I'm gonna let me go ahead and wrap my lines too as well. I'm gonna go to view and wrap lines. But when I say initial value, think of it in terms of a seed. Just like a plant can't grow, a plant can't grow until a seed is planted, right? A seed is planted and watered and whatever, right? But that plant starts from a seed. And so from that, right, it it grows. It can grow. And so that's exactly what you need to appreciate about the control variable. Its value must start somewhere. So give it a seed, a starting place. Any questions about the first requirement? And we'll talk about how it all fits together, of course, right? We're gonna write some code in a minute after we go over these three requirements. But the first requirement is that you must identify, first of all, what your control variable is and give that control variable an initial value before the loop begins. Questions, concerns? Thumbs up if you understand. So far, so good. Okay, thank you, thank you. All right, so let's talk about the second thing. So the second requirement is when we involve a condition. So your control variable should be a part of some condition. So the control variable. So here's what I'm going to put as the third requirement. You must have a condition. When I say condition, that simply means a Boolean expression that involves or contains the CV. So you're going to have a condition. So first of all of these loops have conditions or Boolean expressions involved. Some truth, depending upon some truth value, right? And when you build your Boolean expression, it's a good idea to involve, it's a good idea, and it doesn't have to be, but it's a good idea to involve your control variable, okay? Your control variable. So that's what we're gonna, so again, we'll demonstrate this, but where that control variable is, right? Where that condition is depends on which type of loop we're talking about. But yes, that's one of the requirements, is that the condition, you should have a condition that involves your control variable. The third requirement, and I'm going to put a little asterisk about the third requirement because it's kind of, all of these are important, but definitely number 3 is important. We could have some problems if you omit the third requirement, and I'm going to demonstrate that to you today as well. But that third requirement that every loop should have a way to modify. So the control, I'll say the CV value must be modified or updated, right? Okay, so we've got to modify or update, and I'm going to say in the loop. Okay, this is a requirement. So the CV's value, the control variable's value must be modified or updated, right? In the loop, somewhere in that loop, you've got to change the value of that control variable somewhere inside that loop. If you do not, I'm going to put, like I said, I'm going to put a little asterisk around this, it could lead to some problems. And we're going to talk about what kind of problems that leads to. It has a special name. So we'll talk about that third one. But we're going to look at all 3 of these things. But these are your 3 requirements. Every single loop that we're going to talk about, all 3, the while loop, the do while, and the for, all have these requirements. You should initialize your control variable prior to the loop. Meaning give it an initial value. And then the second requirement is that you should include a condition that involves that control variable. And then the third requirement is that you must, somewhere inside of the loop, no matter which loop we're talking about, you should update the control variable's value. Okay. Questions and concerns so far? We're good. These are the 3 requirements. We're going to see where these 3 requirements are with respect to the syntax of each loop. These 3 requirements are in a different place, different location. So now let's learn the syntax for the while loop. So now we're focused on this while loop. That's the first type of loop we're going to look at. And so the while loop looks like this. Here is the syntax. Let's look at the syntax first for the while loop. So here's the syntax. The syntax for the while loop looks like this. It's the keyword while, open and close parentheses, and then our open and close curly brace, And I always like to do this. I always say this is the end of the loop right here. I like to put my little comment to indicate that this is the closing curly brace for the loop, for the body of the loop. What goes inside of the open and closed curly brace is the body. This is the body of the loop. The statements to be repeated. So any statements, those one or more lines of code that you want to repeat. And I could put that there as well. So those are the one or more lines of code that go inside of the open and closed curly brace. Those one or more lines of code that you want to repeat need to go inside of that loop, right? Inside the body. This is what we call the body of the loop. And we'll also put a little note here, the body of the loop. That's what we call the body of the loop. Anything inside the open and closed curly brace is what will be repeated as long as the condition is true. So let's talk about what goes inside of these parentheses here. So we have our keyword while, and it is a lowercase word while. Okay, it starts with the lowercase w. It's a reserved word, which you'll see when we start writing our code. You'll see it change colors on us. But after the keyword while is an open and closed parentheses. What always goes inside of your open and closed parentheses is the condition. The condition or Boolean expression, they mean the same thing. Okay? Boolean expression, they mean the same thing. So whatever, so this, we always know Boolean expressions evaluate to be what? Either true or false. Either true or false. And so our Boolean expression is what is going to be placed inside of that condition right here. Inside the open and closed parentheses. Any questions so far about the syntax? So this is the basic syntax. The basic syntax, the keyword while, open and closed parentheses, open and closed curly brace. Now, that's the end of the basic syntax for the while loop. Let's talk about those three requirements with respect to the basic structure of a while loop. So those three requirements, where will those three requirements be with respect to the while loop? So the first, put it in the chat real quick. What did I tell you the first requirement was? What was the first requirement? I want you to just rattle them off. I need you to just know them. What's the first requirement? Requirement number one. I'll wait on you. It didn't have to be all formal, but just tell me what you heard. What did you hear from me when I said the first requirement is what? What's the first requirement? What is the first requirement? Anybody? Anybody? Am I talking to myself, or was anybody taking notes? Or okay, so it's initialize the control variable's value. Yes. If you don't have that note, thank you, Zoe. All right, so if you don't have that, make that note, okay? Because these are the kinds of things, you all, that I'm gonna be looking for. So look, what is the first requirement? Is that we given our control variable an initial value. Where is that gonna take place? With respect to a while loop, here's what happens. It takes place, that first requirement is gonna take place before the loop, before the while loop. So the first requirement here, where we initialize our control variable, it takes place somewhere. Doesn't have to be right immediately, but it's going to take place somewhere before the loop begins. So initialize the CV. That's what happens here. Somewhere before the loop begins. You've got to give that control variable an initial value, a seed. Okay? That's the first requirement. With a while loop, it always takes place somewhere before the loop begins. Somewhere before the loop begins. The second requirement, put the second requirement in the chat for me, please. The second requirement. A condition that involves our control variables. Absolutely. Thank you. Well, where in the world is that second requirement with respect to the while loop? a condition. It's right here. This is where that is, right here. Here's the second requirement right here. That's number 2. It's going to be inside of the parentheses. That's what number 2, the second requirement, where we have a condition that involves our control variables. That it's going to be right there inside of the open and close parentheses, right there, right after that keyword while. And the third requirement. Tell me what the third requirement is. I'm going to start calling names. Awesome. I heard you. Let's and thank you, Ryan. I see you there. Thank you all for participating. Yes. Awesome sauce. We're going to do what? The third requirement is somewhere. Let's just say it. Somewhere. It could be anywhere inside, but it must be inside of the body of the loop. Okay. So somewhere inside of the loop, we're going to do what? We're going to update the CV's value. So update or modify the CV. Okay. That's exactly where it takes place. Know this. Okay. And I'm going to tell you this, especially if you're new to coding, you're new to programming, you're new to this loop stuff. Sometimes novice programmers will forget number 3, and that could cause problems. Again, I'll show it to you. But yes. Any questions over any of these so far? Thank you, Isaac. I see you too as well. Ian and Zoe, all of you all who contributed. Thank you so much. Any questions over the syntax, basic syntax here for a loop? Let's look at one. Let's look at this one real quick, and then we're going to write our own. So if we want to print to the screen, welcome to Java 100 times, what will we need to do? Well, remember we said that system.out.println statement is what we want to repeat. So guess what? That's what's going to be inside of the body of the loop. Now, how do we write our condition? So what is going to be our initial, where we initialize our control variable? Well, right here, do you see where in the statement where you see here, it says int count equals 0. Now, don't get all, busy on that or caught up on the value 0 there, because we can initialize count anything, really, we could have. But the point is I gave count a value. I gave it a value, used the assignment operator, gave it a value. It's stored in memory. So count is what that variable is going to control how many times I'm going to print welcome to Java to the screen. That variable called count. Count is my control variable. It's going to control how many times I repeat this loop. So with that being said, I'm going to start it here. I'm going to start it at 0. Well, here's my while loop right here. What's inside the open and close parentheses? The Boolean expression, the expression that evaluates to be either true or false. Remember, the second requirement says that I must include what? I should include my control variable in my condition, right? Involve it in my condition. And so my condition, what am I asking? I'm saying, hey, as long as count is less than 100, now remember how many times did I want to print welcome to Java to the screen? I wanted to print 100 times. Well, because I started my seed at 0, do you see why I used the less than symbol and not the less than and equal to? Because, hey, what if I wanted to start it at 50? If I started at 50, somebody would tell me real quick, and this is just temporary. But if I started my count at 50, then what would I need to change my condition to? What would I need to change the condition to? These slides are in part A. Slides are in part A. So yes, 150, absolutely, Gavin, absolutely. Does everybody see how I'm modifying that? Does everybody see that? So don't get caught up on, all I know is I want my body to repeat 100 times. Whatever that seed is, I've got to make the adjustment. So if the seed is 0, then I know, right? So you've got to craft, you got to be very careful how you design your Boolean expression, right? Like your condition. You want to make sure that it satisfies your requirements, right? And so we know that we want to print 100 times. So based off of the seed, that will help me craft and design the Boolean expression exactly how it needs to be, okay, to meet the goal. And so here for this example, you can see what is inside of the loop. What's inside of the body of the loop? Well, there's the statement that I want to repeat. As long as that condition is true, you're going to get permission. Now, listen to the words I'm saying. As long as this condition is true, you get permission to execute the one or more lines of code that are inside of that open and close parentheses. When that condition becomes false, guess what? You do not have permission to come inside and execute those one or more lines of code that are inside of the body of that loop. So this condition is the gatekeeper. And I'm going to use my little analogy. Let me just stop. I'm going to use my analogy. Some people get, I have so just follow with me here. Imagine we're at a club, okay? We're at an exclusive club, okay? Have you ever seen a bouncer at the door? And maybe we're in the VIP section or something. I don't know. Let's just use our virtual imagination here. So look, we're at the VIP section, and if your name is not on the list, let's say, we'll just say the first 50 people that come in, right? The first 50 people can come in or whatever, right? So that bouncer at the door is what we call the gatekeeper. That gatekeeper has a counter or whatever, and it's counting every person that comes in. And after that 50th person, it's not going to let anybody else in, okay? So that bouncer is, like we said, the gatekeeper. Well, so is this condition. This is the gatekeeper. And as long as that gatekeeper, so long as this condition is true, you can come inside the club. But when that condition becomes false, you do not get permission to come inside the club. And guess what? The next line of code outside of the loop is executed. You never go back. You don't go back to the while loop at all. But that, as long as this condition is true, come inside. So here's what you need to appreciate about a loop. After the very last line of code inside of the loop, what do you have to go back up to? You have to go back up and think like a computer. Once the computer executes the last line of code inside of the body of the loop, it always goes back up and checks the condition. After it checks the condition, depending upon the truth value of that condition, that determines what happens next. If the truth value is true, it will execute the body of the loop again. If the truth value of that condition is false, it's going to jump out of that loop and execute the next line of code outside of the loop. That's how all of the loops work. That's how all of the loops work. So any questions over the syntax here? Look what happens. So when the condition is true, let's say the first time we go through the loop. The first time we go through the loop, the computer's asking the question, is 0 less than 100? Yes, 0 is less than 100. So because that's true, the computer's given permission to come inside and print welcome to Java to the screen. After it prints welcome to Java to the screen, what is going to happen? It's going to execute the next line of code, which then does what? Before you go to the next iteration, you're going to add 1 to count, to the value of count in memory. So you're going to go to memory, going to find that count is 0, add 1 to it. So now in memory, count is 1. And so then what happens? Then you have no choice but to come back up here now and evaluate that condition again. Now, on the next iteration, what you're asking, is 1 less than 100? And you can imagine that goes on and on and on and on. So when we finally get to the place where I'm adding 1 to count, and let's say count was 99. Let's say that now I'm adding 1 to count. Now count is 100 on this iteration. Well, then when I come back up here and I say, hey, is 100 less than 100? No, it's not. So you do not get permission on that iteration. You do not get permission to execute the body of the loop, those one or more lines of code that are in the loop. So guess what? The computer's then going to jump out of the loop and execute the next line of code that's outside of the closing curly brace, right? So outside of the body of the loop. That's how it works. Questions or concerns about any of this? Any of this? So you can kind of see, I just kind of did a little one here for you, just to trace it. So what if we had something like this? Look at what we have. This is count, and I initialized it to 0. And what if I have a condition like this? It says, as long as count is less than 2, come inside and print. Well, if this were the case, what's going to happen? The first time through, count is 0. So is 0 less than 2? Sure it is. So because it's true, you get permission to come inside the body of the loop and print welcome to Java. Then we're going to go to memory and update memory, right? Now count is 1. Then what do we have to do? Think like a computer. The computer is then going to go back up to the condition and evaluate the condition again. It's going to say, hey, is 1 less than 2? Sure it is. So you get permission to come inside and print welcome to Java. What happens next? We update count's value, right? Now count is 2. And now what happens? The computer goes up and evaluates the condition again. And now it asks the question, is 2 less than 2? No, it's not. So guess what? You do not get permission to come back inside the body of the loop. You must execute the statement, the next line of code that's outside of the body of the loop. All right, that's how it works. It's a breeze. You got this. You got this. So let's do this. Before we write some code, let me just tell you what the while loop is called. And I'm going to ask you this again, and I want you all to know it. What is the while loop called? It's actually called a pre-test loop. And I'm going to prove it to you in just a second. A pre-test loop. Let's make sure we make note of that in our statement here. So in our notes, the while loop is called a pre-test loop. Okay, I'm going to prove it to you. What do we mean by pre-test? The way that the while loop works, unlike the other two, is that you must check the loop's condition before you ever get permission to come inside and execute the body of the loop. You must check the condition. That's why we call it a pre-test. We're testing the condition first before you execute the body. So let's make a little note of that in our notes as well. So I'm going to put a little note here for myself. So here on the loop, it's considered a pre-test loop because I will say pre-test loop. The loop executes. Let's say that. Yeah, the loop executes 0 or more times. Okay. I left our word here. The body of the loop executes 0 or more times. Let's put it that way. The body of a while loop executes 0 or more. That's very important, and a very important distinction between this type of loop and the other loops, the other 2 loops that we're going to talk about in just a second. Okay. Very important distinction. 0. So there may be a case, you all, guess what? There may be a case where your loop never executes. It just depends on the gatekeeper. Remember the bouncer at the door? Well, what if what if whatever the capacity is, we're already there. So nobody ever gets, what if the capacity was 0? Okay, then you don't get permission to come inside, right? Or whatever the case is. I'm going to give you an example of what I mean by the gatekeeper, and there are circumstances where your loop never executes. Again, we're now dealing with much more complex structures, right? As soon as we started introducing branching statements and loops and things of that nature, right? These are a little more complex. Not every line of code is going to execute in your program. It just depends on circumstances and conditions. Thumbs up if you're with me. Ready to look at some code? Ready to write some code? All right, very good. Let's write some code. Let's go ahead and why don't we do the little, you want to do the little robot? Let's call, exactly, Gavin. Let's go in code. Let's go ahead and right click you all. And I'm going to call them, let's do the robot. Let's say the robot. Robot walking. Okay, let's do that one. Why not? We can simulate it. We're going to simulate it. All right. Let's go ahead and copy our template here inside of our robot walk-in. Okay, robot walk-in. Go ahead and make sure you change the name of your class to robot walk-in. All right. So we're simulating. So let's put a little purpose here for this program. Let's define the scope of our program. What do we want our program to do? And you all chime in. Okay, let's brainstorm. I'm open to trying some new things here, right? If you have some ideas, what you want the robot to do, but I want to use a loop. So let's go ahead and why don't we do this? Let's make it interactive. Do you want to make it interactive? Well, let's first just say we're going to walk a certain amount of steps, and then we'll edit our program. where we'll ask the user how many times we want the robot to walk. But we'll do it first. Let's just hard code it. Okay, so here what's the purpose of this program? Purpose of this program is to make our robot walk a number of steps, right? Make our robot, Mr. Robot, walk a set number of steps. So that's what we're going to do. We're going to make our robot, Mr. Robot, we're going to make Mr. Robot walk more than, walk a set number of steps. Okay, so that's the goal. All right, and here, I also want to, another additional purpose here is to demonstrate a while loop. Okay, a while loop. Just for documentation purposes, when you look back at this code, you'll know what we were trying to do, okay, on February the 24th. What in the world are we trying to do? Well, we were trying to make sure that we understood in the concept of a loop, right? First of all, right, and the syntax of a while loop. All right, so here, now that we have it, let's go ahead and put a little outline. Let's write our algorithm. Let's think it through first, okay? So we know we're gonna need to declare some variables. Gonna need some a variable here or there, right? And then we are gonna use a loop, right? Use a loop to make our robot walk. That's what we're gonna do, okay? And then let's have just a simple print statement. Let's say we'll print after robot walks, right? Print a statement. We'll just say print a statement after the robot walks. Okay, so that's our game plan. Again, it's just an example. So what do we need? Remember those 3 requirements. We gotta identify some variable that's going to control how many times our robot is going to walk. Does everybody get that? Got to have a variable. Call it a control variable. So at least, now there may be some other variables needed, but not really. But you know, we had a bigger problem, but our scope is kind of small here. But we know that we're gonna need to declare some variable, right? And so I'm gonna declare a variable. We can call that variable anything that you want. We could say steps. Well, let's maybe call it steps. I don't know. Okay, again, you can call it whatever you want to call it, but we know that that variable is going to be in our minds. It's going to be responsible for controlling how many times this robot repeats the walking, right? The steps taken. All right, so look, now we need to give this control variable an initial value. You can do it here or somewhere later in the program, but here we know we need to do it before the loop begins. So let's go ahead and let's get it started. So again, we can tell it, we could start this value anywhere, but I'm gonna just say, let's say we haven't started walking at all. So I'm just gonna start my initialize this control variable to 0. We haven't started walking at all yet. So this is the control variable. So here, what am I doing? This is that requirement number 1, where we are initializing the CV. That's what we're doing in that 1 line of code right there. We're giving our control variable a seed, an initial value. Okay. So now that we got that first requirement out of the way, we needed to do it somewhere before the loop begins. And there it is. Now, we know that we're going to need a loop because walking is repetitive. Lift my right foot up, put my right foot down, left foot up, left foot down. That's repetitive. Walking is repetitive. That means we need a loop, right? You got to repeat those things, that task, that activity. We got to repeat it. So therefore, I'm going to introduce a loop right here for the walking because I want to repeat 1 or more activities. 1 or more lines of code need to repeat. So I'm going to start my loop off with the keyword while. There's my open and close parentheses for my condition, where I'm going to place my condition. I like to set up my loop first before I start writing any code inside of it. So there's my open and close parentheses. There's my open and close curly brace. Please get in the habit of commenting your closing curly brace. Please do this because our programs are going to be much more complex, more and more complex. We're going to have some, we're going to be learning about arrays and loops and all kinds of stuff. So tell me what this closing curly brace is. This is the end of the loop. Just put a comment for yourself. Documentation, you all, is so important. Okay. Think of it like this. When you're in the real world, you're going to be writing code with others. You're going to be looking at other people's code. So let's just learn good behavior, good programming behavior now versus having to train yourself once you get on the job. Learn how to document your code properly as you're typing your code. Don't have to, All right. So with that being said, now we have our loop. Now let's go ahead and help me out here. So what do we know? That our second requirement, I'm going to put my little second requirement. The second requirement says that we have a condition that involves the CV, the control variable. So help me, someone. Let's assume that I want let's do this. Yeah, let's assume that I want my robot to walk 10 steps. Let's assume that. Okay, I'm going to put that in as my assumption right here. Well, no, because I'm going to modify the program. Let's assume that I want my robot to walk 10 steps. Help me craft a condition, a Boolean expression. So and the Boolean expression that you need to craft is write a Boolean expression that will make our robot walk 10 steps. Right? Walk 10 steps. How do I tell the program? How do I tell the robot to walk? Every iteration, I'm going to take a step. Every iteration, I'm going to take a right and left step. Every iteration, I'm going to take a right and left step. Every iteration, I'm going to take a right and left step. When should I continue to take a right and left step? Under what circumstances? How do I state that? Given my control variable and what I've initialized it as, can someone help me with my condition? Under what circumstances will I walk? If I want to take 10 steps, help me craft my condition. As long as what is the case? As long as steps is less than 10, absolutely. Thank you. High five, you all. High five. So as long as steps, and you need to use that. So that's the control variable that I've defined. So as long as steps is less than 10, because I said I want my robot to walk 10 steps. As long as steps is less than 10, keep walking. Is everybody good with that? Okay. So with that being said, now, what do I want? I'm inside the body. Right here, I'm inside the body. So if I'm inside the body, what do I want to repeat? What do I want to repeat? We're simulating here, okay? Let's just simulate. I'm just going to print to the screen, system.out.println. I'm just going to print to the screen, lift, right leg, right foot. Set down, set down, lift. Maybe I'll even do, let's do this, lift, left foot. I'm gonna say and set down. Let's just do that. Again, we're just simulating, okay, does everybody understand that? And set down, all right? So lift right foot, set down, lift left foot, set down. That's what I want to repeat. Okay, this simulates me walking. Don't forget your semicolon here at the end. So this is me walking right here. I'm going to put a little note for myself here. This is walking. Robot is walking. That's what robot is doing right here in that print statement. It's walking. Questions for me so far? Okay, so then what do we know? We have a checklist. Have I done requirement number 1? Yes, I've initialized my control variable's value. Have I done requirement number 2? Yes, I have a condition that involves my control variable. Have I done requirement number 3? Have I? No, I haven't. So somewhere inside of this condition, inside of the body of the loop, I need to update. This is that third requirement. I need to update the CV value. What do you think I need to do? Do we want to take one step at a time, you all? one step at a time to my upper limit. My upper limit is 10. Is everybody with me? That's how many steps I want to take. So what am I going to do? I'm starting at 0. So am I taking one step at a time? Every iteration, I'm getting one step closer to my upper limit. Is everybody with me on that? So for this problem, how will I update my control variables value? Well, this problem requires me just taking one step at a time. So what will I do? Whatever the control variable is, I can add one each iteration using that. Remember the post operator, or we could do that. So I would add one. Yes, let's.
You put step is less than 10 because of the number of steps, or just 10 to liberate the problem?
So repeat that one more time. I'm sorry.
Sorry, I had headphones in. Yeah, you put 10 as a random number, or just 10 steps to walk.
So 10 represents my upper limit. I know that I want my robot to stop at 10 steps. Does that make sense? So I just hard coded it there. You get my point?
Okay, I get it. Just
That's what I want. Because my assumption was stop. I want the robot to walk exactly 10 steps. Now there is a better loop to do this with. I'll just tell you that we'll learn about it next week. But we can write it using a while loop as well. So yes, 10 is that upper limit. That means that's where I want my robot to stop walking, is when the robot has reached 10 steps. Now remember, when I say steps consist of me putting my foot up and down for both feet. Okay, is everybody with me? I'm doing those two things on one iteration. So up, down, that's one step. Okay, is everybody good with that? We're simulating. Does that make sense, Les?
Yep, definitely.
Cool. So everybody, we have now. I'm going to show you the problem if we omit requirement number 3, but not right now. So let's do this. If I simulate, I want to write one additional statement outside of the loop, you all, outside of the loop. Let's maybe say, let's put a little print statement here. Let's say, maybe .print ln. I'll say something like, the robot has finished walking. You can put whatever statement there, but I'm outside the loop. Outside of the loop. This is not embedded in the body of the loop at all. It's not, this statement right here is not controlled by the loop at all. It's going to execute no matter what. It's not controlled by the loop. These statements that are in the body of the loop are controlled by this condition. They will not execute. If this condition is false, they will not execute. Okay, but when this condition is true, they get permission to execute. Think of it in terms of that. It's that gatekeeper. Okay. All right, let's go ahead and run this. Unless you have any questions let's run this program. Let's see how it works. Okay, let's see how it works. I'll keep my code up so that you can see the code. But make sure that your program is saved. And let's go ahead and run this. I'm going to say Alt F5 here to run my program. Now, if you see here, look, okay, you can see, I'll try to see so you can see my code here. Lift right foot and step down, lift left foot and step down. So count the number of times we made a step. Remember, a step consists of both right and left foot. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Did y'all see that? We walk, that robot walked 10 steps, okay? Because we told it to. We wrote the code to execute it, to make sure that it did exactly what. So we've got to make sure that our condition is crafted just perfectly like we want. We want to make sure that it's correct, because it will control how many times the body is executed. Any questions over this? Watch what I'm going to do. I'm going to add a little statement here right before my lift right foot and set down, and lift left foot and set down. I'm going to add a little statement here. I'm going to say step. I'm going to say step. I'm going to put a little parentheses here. So I'm going to say steps +1. And then I'm going to concatenate that. So here's what I have, you all. Look, I said, and you can put a little space between them. I mean, it makes sense. I'm just adding 1 to the current value of steps. It's going to print right here. Okay. I'm going to put a little dot here and a little space in front, because what I want to happen is I want you to see the steps as they take place. I want you to see the counter increase as it's taking place. Why did I say steps plus 1? Because where did I start steps at? Steps started at 0. Okay, so I want this consists of 1 step, right? The first time in the body of the loop, that's considered 1 step. So I'm just gonna do whatever the current value of step is, I'm gonna add 1 to it because I want to indicate that. Think about the first iteration. The first iteration steps is 0. Okay, until I get down here, I don't finally increment steps to 1 until after I print. So I want to take the current value of step, add 1 to it, because this is the first step that the user, that the robot is making. Okay, so if I did this and saved it, and I run this program again, you can literally see the steps that are taken as they are taken. Does that make sense? I just wanted to demonstrate to you that we are literally iterating, right? We're literally moving through this loop, right? Executing this loop. Thumbs up if this makes sense to you. Does this make sense? Got it? All right. Y'all are almost convincing me. Let me prove something to you before we shift gears. I want to prove to you, remember I told you two things. I want to prove to you that, first of all, that that third question, Lance.
Can you scroll up one more time? Scroll up to the first.
That's good?
Yep.
Okay. So here's what I want to prove to you all. I want to prove to you all this. So I'm going to make some minor modifications. We'll change them back. But I want to prove to you all that if you omit step 3 in your requirements, you could cause some problems. Y'all ready for it? Okay, you could cause some problems. Here's what I'm going to do. Now, remember, we're gonna just modify it slightly and we're going to change it back. But I want you to do this. I want you to put a comment in front of that requirement number 3. So where we're saying step plus, put a comment in front. And now we're going to run this program again because I want to show you something. If you omit step 3, meaning we don't update steps value, then steps is going to, I won't even tell you. I'll let you see it. I'll let you experience it. Let's go ahead and run this program. Let's see what happens if we commented out step, our third requirement. Can someone tell me what in the world is going on? Can someone describe this? What is this an example of? If you omit the third requirement where we update the control variable's value somewhere inside of the loop, what will this cause? This has a certain, what does this cause? What does this look like? Is yours running crazy or is it just mine? Is anybody here? Hello? It's a continuous loop. Yes, an infinite loop. Yes, write that down. I'm going to put in that, you can push the little stop button, that'll stop it. Because it will go on infinite to infinity. Why? Because we call this an infinite loop. An infinite loop. We never change steps value. So it stayed absolutely, it stayed 0. And then we don't want that. That's bad. You never want to design a loop that's infinite, that never ends. Oh, that's bad. So let's put that, take those comments off. I just did it for demonstration purposes. But if you omit the third requirement, meaning you've not updated, it doesn't mean add 1 to it or whatever. It just means update. And it depends on the problem, how you're going to update the control variable's value. So it depends on the problem. I can't say if that, we've got to take a look at the problem and figure out what do you need to do to update that control variable's value that's going to satisfy the problem at hand. So, but if you omit it, it's going to cause problems. You're going to create an infinite loop, but you'll know how to fix it. If you do run into it, you should know how to fix it. You know, oh, why is it running like that? That means I did not do step 3, the requirement. I didn't include the third requirement. Another thing I want to show you before we get out of here is I want to show you, demonstrate why we call the while loop a pre-loop. A pre-loop. Watch this. So pre-loop just simply means this. Let's say, for instance, watch this. We're gonna make this change, but we're gonna undo it after we demonstrate. After I demonstrate this, but add a 1. So I want to initialize my steps to 10. Not 0. I want my seed to start at 10. Please do that for me, please. Just for demonstration purposes. We'll change it back. But let's initialize it to 10. Don't change anything else. Make sure you taking those comments off step 3, right? Make sure you uncomment that. But I want you to make your seed 10. Now, save it and let's run. What am I demonstrating? I'm demonstrating to you right now why the wild loop is considered to be a pre-test. Because just like the bouncer at the door, if I'm already at my limit, you're not coming in. If I'm the bouncer at the door and the condition is 10, then you're not coming in. I've already walked my 10 steps. Is everybody with me on that? The robot's already walked his 10 steps. It's not walking anymore. It's going on strike or whatever. I don't know. But look, it's not walking 10 more steps. It's we're done. So that loop never executed. Why? Because the seed was 10. Based off this condition, the condition says, hey, as long as 10 is less than 10, 10 is not less than 10. That condition is false. Because the condition is false from the jump, from the start, you do not get permission to come and execute the body of the loop. So this is an example of where it's a precondition. This is why in our definition, I told you what, that a pre-test loop, a wild loop, the body of the loop executes 0 or more times. So it may never execute. And on Tuesday, I'm going to show you another type of loop called a do while loop, which is a little different than the wild loop. It has a different nature and it runs a little differently. But the wild loop is pre-test. You must check with the bouncer before you can come in the club. You must check with the bouncer. And the bouncer says, no, I'm sorry, no entrance. Okay. Now the do while is something else. It's a little more liberal. Okay, it's a little more liberal. But is everybody good with this so far? These are the concepts that I wanted to go over today. I'm done. I'm going to drop the mic and I'm done for today. We've done a lot, whether you realize it or not. But this is a good introduction. You have enough to get started with lesson 5. Okay, so let's get started with lesson 5 over the weekend. And you all have a great weekend. If I can be of assistance, let me know. If you have any questions, hang around. Okay.
Thank you, Professor.
Bye. Have a great weekend. Thank you. Take care.